Learn. It is a Python library for machine learning. And from sklearn, there is a package known as model selection. From that particular package, I am importing a train test split, a method named train test split. So what does this train test split does? This train state is just splits the data into training set and testing set. As I have mentioned earlier also, that we have to divide our data set into two sets, that is training sets upon which the model will be trained, and the testing set upon which the model will be trained. Okay, so what is happening here? So the train test split is happening over the housing data set, or since we have stored our data set in this housing variable, that's why it is in the housing data set. And the next parameter that I've included is test size equals to 0.2. Okay, so 0.2 it correlates to 20%. Okay, so 0.2 is 20%. So we are actually dividing. So actually what it is saying there, it is dividing the test set and the training set into 80% and 20%. That is 80% training set, 80% of the data points are going to training set, and 20% of the data is going to the test set. And we are storing those into a respective variable, that is train set and test set. It is quite evident. It is not much of a complicated code that is going on right now. And I've included another thing, random state. Okay, random state is a very good feature that sklearn allows, almost for all methods. So what does this random state does? It splits the data in a random fashion, but it gives it a tag name with 42. This 42, this number is randomly generated number. You can use any number. Okay, I have used 42. If you use 42 in your code, my data, the way my data will be divided randomly, it will pick up data from the data set and will put it into training set and test set. The way randomly, the way it will pick up data from my data set, it will be same for yours also. This is a very good feature that sklearn gives us. Now, as a homework, I would like you to explore that why I am writing 42. There is a mathematical reason that I am writing 42. It is globally accepted number, that is 42 is written in the random state. Why is that? I would like you to explore that thing and tell me tomorrow about all about it. Okay, so now I have said, Jay, that training set and the testing set is being divided. Okay, so you can say, Jay, okay, so show me the testing train set. Okay, let me just print the train set. What happens? Look, here is the training set. If I draw your attention to the index number, look at it. Every index number is like random. So it is randomly picked up data points from the data set and put that thing into the our training set. Same goes with the testing set also. But remember, when we started our project, we learned our first library as housing.head, and the second one we learned is housing.shape, which gives the number of rows and number of columns. The first parameter gives you the number of rows, and the second parameter gives you the number of columns. So here in the entire data set, we have 20,640 points. If you take the 80% of 20,640 points, then you will get a number which says 1600, 512. Okay, same goes with the test set shape. Four hundred, 112. If you just add them up, you will get 20,640 data points. So it is indeed that the data set is divided into two parts. But as I said, this is a random way of random way of dividing the dataset into two parts. Okay, and we are not going to follow this because our dataset is not very large. Generally, when you are doing a machine learning program, you don't go for stratified sampling. But since we have less number of data points, uh, I am going for stratified sampling. Okay. And to be honest, I am also doing this because you need to understand what is stratified sampling. And some of you, if you have done any kind of machine learning, it is very very high chances are there that you have not heard this stratified sampling thing. So it is very important, and since it is very important, sklearn provides us a library, and then the scikit-learn also provides us with a library called stratified shuffling, to do this stratified sampling over our data set. It is that important that sklearn included a library specifically for this. That's why it is not that unimportant, I guess. So let's just do that. Okay. So generally you will when you are doing your uh, machine learning project, you do a train test split and split the data like this. Okay. But since you need to learn stratified sampling, that's why I am also doing stratified sampling, and we will be using stratified sampling only. But but there is a problem here. Let's get back to our median income. Okay, let's get back to our median income. You spoke with your boss about your median income, and your boss told you another mind-blowing fact about this median income. What did your boss say? Your boss said, Jay, this median income is a very important attribute, and since it is a very important attribute to predict the final house value, you may want to ensure that the test set represent various categories of this income. Now you are said, Jay, okay, the median income has is a continuous data. It is like flowing. You can see that the data is continuous. You can draw a line with the data without lifting your pencil or pen. So it's a continuous data. But your boss suggests that it is better that if you can divide this continuous data into separate categories, so that it can be of great help. It will be of great help that if you divide this median income into certain categories. So you ask your boss, okay, what categories should I split into? Your boss says you should split the entire data into 5 categories. First, one, two, three, four, 5. That's all. That's how you need to do it. You say, okay, though then I need to divide the data into categories. That's what your boss said. Okay, your boss said you have to divide the data into categories. You have to convert your continuous data into categorical data. I am not specifically categorical data. You have to divide those continuous data into categories. So how do you do that? So let me just make a new column. We have 10 columns. I'm adding a new column known as income cat. Okay, which contains categories. Okay, I need to import NumPy, I guess. Okay, NumPy is another library, Python library. It is used for mathematical calculations and all. It is a very good library, and I would prefer that you should explore that library on your own, because it's quite big and it has various usage. Okay. So what I am doing here, I am taking the income uh, column. I am taking the income column and dividing each value with 1.5, dividing each value with 1.5, and taking the seal value of it. Get it clear? I am taking every point in the median income column, dividing that with 1.5 so that I can scale it down. This is also a kind of scaling down. So that I can scale down, I am taking every data under median income, dividing each data with 1.5 and taking the seal value. Okay, I hope that what you know what is seal value. I don't need to explain what is seal value. And since your boss have told you that you need to uh, divide this into 5 categories, so you have to do that in 5 categories only. And how do you do that? This is how you do that. Okay, hope that it will run. Yeah. So what I have done here, I have divided the entire median income into, I have converted our median income into categories. Then I have taken all the categories and squashed it into 5 categories only. Now why I have written this, what is the meaning of this sentence? Let me just explain it to you. It says everything must be less than 5. Every value that we have must be less than 5. If it is going above 5, it is squashed back to 5, the column 5 only. And comma, I have written 5 because we have 5 columns or 5 categories, and in place equals to true means that this directly affects our data set. If in place is by default, in place is equals to false, and it does not affect our uh, data set directly. But if we turn this in place equals to true, it directly affects our data set. But how do we understand that the data is splitted? Let me just pull up our data so that you can understand. Let me just pull up my entire data set first, so that you can get a good better understanding that what we are actually doing right now. Now look at it. We have an extra column named income cat, and we have 5.0, 5.0, 4.0, 3.0, like these values. As I have said that I have divided everything into every value of this median income by 1.5 and taken the seal value, and then squashed all the values between 1 and 5. So now the entire 20,640 points have been categorized. The median income have been categorized into 5 distinct categories. Now you can argue that I cannot see those categories. You are just making me look at some of the numbers. How can I see the make sure? How can I believe you that these are only not only numbers? I need to see something, of course. That's why visualization is important, and we need to do our visualization. So let's see what happens. Previously, I have used histogram, right? So I will be using histogram also, but this time I am not going to do the histogram for the entire dataset. I am only concerned about one column. Let me write that column. I am selecting only one column. Where is that column? I cannot see this. Write it. Only one column, that is income cat, and I am going to draw a histogram on this. Okay, we have a histogram here. Now remember one thing. Remember our median income histogram. Look at it. It's a continuous value. You can draw a line without lifting your pen, right? It's a continuous value. But your boss said that you need to divide it into categorical values. Category, sorry, categories. Saying categorical values too many times. It's not categorical values, it are categories. So now it is completely, you can see the data is divided into five categories. There are some 1, 2, 3, 4, 5. Now you can see a greater aspect, you can look at it at a greater aspect. What I can find from this particular graph, you can find J, the people who belong to the category 4 and 2 and 4, 2 to 4 are a greater part of the population, whereas 1 one consists of a lower part of the population. 5, which is known as a high category or very high income category, they also occupy a certain amount of population, but the most of the population is between 2 and 4. So the most of the population belong to the category 2 and 4. What does it tell you about it? It tells you that the most of the data set that is given to you, most of the people, most of the median income are of middle class. The most of the people are middle class, and the number of poor people or the people who have lower income is very less. And there are rich people in here, but not in abundance. Okay, so this is a story that you can learn from it. So now you have something. Now you have something to now the income, median income is divided into five categories. Okay, now we can start our stratified shuffling. Why we I have done this income categories first, then I am going for stratified shuffles, stratified shuffling or stratified sampling. It is important because stratified shuffling or sampling always requires categories. Remember the previous day I gave you an example, J, about the 1,000 people in a survey, that and the number of percentage of men in India is 48 and women in India is 52. Okay, so remember that if you are not given that percentage, if I don't provide you with that information, you won't be able to select people, right? You won't be able to select people. That's a very important thing. You need to have that information, you need to have that ratio or that percentage, so that you can start selecting people. In the same way, in a continuous value, we don't see any kind of ratio or percentage, right? Because it's a continuous value. That's why we are dividing it into categories. If we categorize this value, or categorize the median income, then we can create a ratio. We can create a ratio of 1 is to 2 is to 3 is to 4 is to 5, all the five categories, and get the number. And if we have the number, we can do a stratified sampling. For stratified sampling, we must have the information that how, at what percentage that we have to split the data. If we are not providing it with the particular number, it is not going to work. That's why I divided the median income into categories. It is very important. So let's start with the stratified shuffle split, because it is what is this is the name of the library that we will be using. Generally, it is just stratified sampling. It gave a fancy name to it. Sklearn gave it a fancy name. Let's see. Yeah, we have here. This is why I love Colab. It gives all the code snippets right away. Fingers crossed. Okay, we have it. So what I've written now, it from now on, as I said, the things are going to start getting complicated, and this is the beginning of things getting complicated. Okay. Uh, by the way, if you have a question, just hop right away because it is very important for you to understand. And sometimes people don't understand these things. So what I'm doing right now, I am just importing stratified sampling. It is also known as stratified shuffle split in the sklearn.model selection. I am taking an instance. I'm creating an instance of that of instance or object, whatever you can say. I am splitting it into one section, and the test size is 0.2, and the random state is also 42. Notice that I am always using a random state of 42, and tomorrow I would like you to tell me why I am using that particular number 42. What is the significance of the number 42? Okay, so in the similar way as we used to train test split over here, let me get back to that code. A similar way we use train test split, we have used a test size of for 0.2, that is dividing the training set into and test set into 80% and 20%. Similarly, we are also dividing it here into 80% and 20%. Test size means the test set contains 20% of the data, and the remaining is training set, that is 80%. So this for loop, what it does, if you don't have an idea about how advanced Python or enhanced Python for loop works, you may find some difficulty understanding this thing, but still I am going to explain. There are two variables in Python. You can Python for enhanced Python for loop, you can take two variables at a time. That is, I am taking two variables, that is train set and test set. These are two variables. It's like uh, for I equals to, if you are from Java or C or C++, it's like for I equals to 0 semicolon, j equals to 0 semicolon, then you write the condition, then you check the condition, then you increment the value. Similar way, I am taking two variables. Now I am doing a split. Remember, this split is this variable, and dot split that I am using again is the method that it provides. So it takes two parameters, that is, the one is the data set, and the second parameter is upon which the data set is going to be split. We have created this income cat specially only for this stratified sampling, and that's why I am taking it as the second argument. The first argument is the data set, second argument is the column upon which the splitting will be done. And I am using two variables to store my training set and test set. So that is strat train set. I am training just taking all the values taking all the values from the data set and putting it into the training strat test set, sorry, strat train set, and taking all the indexes of the test set into the its respective variables. So now if you look at it, if you look at the size of that it has to be like 16,512 as I remember it, I guess. Let's see. Oh yes, we have 16,512. Remember that we have 11 columns here, but it previously used to have only 10 columns. Okay, this 11 column is not is just the income cat column that we added later. Okay, so similarly, if we check our test set shape, then we are going to get the same number. So the data is being split into two parts. Okay, it is it is a very, what do I say? It is by this you can understand that it has been split. Now let me tell you, let me give you another information. Let me just explore the income cat that we created right now a little bit more, so that you can get an insight that what we have here actually. Remember that here over yeah, remember this housing ocean proximity, and we used method name as value counts to get all the numbers of occurrences of that particular categories. Similarly, I am going to show you that there are only 5 categories in here, and that's how I am using that value count method over this particular column. So let's see what happens. Okay, now look at it. There are 5 categories: one, two, one, two, three, 4, and 5. So we can see the third category contains 700 and 236. Second category contains 606,581 data points, and similarly all those one. So here, from here, I can you can be assured there are actually only 5 categories that we have divided our data into. So there's no sixth category. Any data which is beyond that particular 5 category is squashed into fifth category only. Okay, so this is where our splitting of data is done. This is a very crucial moment for our model, because from now on, it is very important to understand this thing when we are training our model. Okay, when we are training our model, we are only going to use our training set. Testing set must be remain should remain untouched. It's like, uh, before going to the exam, you can read as much as you can. But if I give you the paper, if I give you the test paper before your exam, you will read all the questions from this paper, and come sit for the exam, or take the exam. You will score 100%, but that won't be an morally accurate. Similarly, if somehow our model gets the test set as input, huh, then it will give you 100% accuracy. Of course, it will give you 100% accuracy, but when it comes to an unknown data, it won't be able to give you a good accuracy score, because it has cheated at some point, right? So it is very important to separate these two things, that is the train set and the test set. Okay. Okay, so we have split our data. Now we don't need our income cat column. We have only used that particular column for splitting our data. Now we don't need it. So just delete it. Okay. So what I am doing here, it is nothing much. It's like a normal set only, normal for loop only. So I am selecting the income category or income cat column from both the training set and testing set. Okay, and I am dropping it. Deleting a column or a row in scikit-learn is known as drop. We use drop. We will be talking about this particular drop method in a very elaborate manner later, but still you need to understand this drop, what this drop does. This drop deletes, that's all. Deletes, it deletes things. Okay, so what is the next parameter that I've given? It is axis equals to 1. What is this axis? Axis means actually two things. That is, actually axis represent two things, that is columns and rows. So by default this axis is rows or 0. Rows is represented by zeros, and you can turn it into columns or uh, what do I say, columns are 1. Since we want to delete a column, we are not going to delete a row, we are going to delete a column. That's why I have written 1. Instead of 1, you can write column, entire, column, column, or rows. It will take it. I am not going to rerun this, because if I rerun this it will generate an error. Okay, and in place equals to true, as I said, these are some of the common attributes that we will find in every scikit-learn method. In place equals to true reflects those changes into the original dataset. Okay, yeah, by default it is turned as false. Now, before moving on, I am going to, first things first, that I am going to take our housing variable, which contains our entire dataset, and since, as I said, we are only going to work with our training dataset, that's why let me just take the strat10 set dot copy, okay, and execute it. We will be working with this housing variable, not this straight train set, because by any means, fingers crossed that nothing happens to our training set, but by any means does something bad happens with this training set and it gets destroyed, right? And then you have to do this all over again. That it is wise to do things, or copy the entire data set, entire training data set over into a variable and use that variable. If something goes wrong, we still have our training set, right? We don't have to rerun everything. So this is where, now if you can see, we previously we have our housing shape is housing shape, as we saw in the very first, we have a housing shape as 20,640, but now we are only considering the training set. We are not considering the entire data set, so it should be around 16,000 something, or I don't remember the exact value. Let's see. Yeah, 16,512. It is definitely reduced. So we have 80% of the data. Now I would like you to draw your attention that there are only 10 columns here. And even if we print our data, we can see that there are only 10 columns. That income cat is being deleted. Now, do you people have any kind of problem? Or I am just going to paste these snippets into the chat if you are having trouble writing those or copying these things. Hello, I couldn't join the first session. Can anyone? Yeah, you can just watch the YouTube video that we have recorded, so that's not a problem. If somebody is having a trouble, just copy these things, you will get your problem. Otherwise I think it's good enough. It's not a lot of a code that we are going to use. So we are today we are only doing this. I'm not starting with anything else. Tomorrow we are going to do a lot of stuff, and by a lot I means a lot. Okay, we are going to do a lot of stuff with tomorrow, but today this is where I would stop. Please join tomorrow a little early, at time and at particular, at exactly at 4 o'clock, because tomorrow we have to do a lot of things. We have a lot to cover. That's why. Now, do you people have any kind of questions right now? If you have any questions, please please tell me right now, or you can ask them in the WhatsApp group. DM me. I'm available. I will answer as soon as possible. And hope you people are understanding, because from now things are going to get a little bit, when it will start getting a little bit complex. Okay, guys, so if you don't have a question, you can leave. We are done with today. Please join tomorrow at 4 o'clock exact, because we have a lot to do tomorrow. We have a long session. So enjoy your evening. You can sign off.